In the previous video about ideal gas law, in which we were able to derive density from PV is equal to nRT, which is the ideal gas law, we were able to come up with a formula of density in terms of ideal gas law, and we came up with density is equal to the product of pressure times molar mass. So mm means molar mass, that's just one value, divided by the product of gas constant times the temperature in Kelvin. Now, before we start applying this formula to a certain problem, we have to derive first the unit, the final unit of density, if we use this particular equation. So what will be the units that will come out if we put the desired unit according to what is being dictated by our R? We know that because of R, P has to be in atmosphere. And then molar mass, there's no other unit for molar mass because it's the mass of 1 mole of any substance. So therefore, the unit of molar mass is always grams per mole. Because again, the definition of molar mass is the mass of 1 mole of a substance. Divided by the unit of R, which is, it's liter dash atmosphere per mole Kelvin. And then, of course, temperature has to be in Kelvin. So let's now remove the units that we can possibly remove from this particular units of each variable. So atmosphere is obviously cancelable. And then your mole here and that is also cancelable. And obviously for per Kelvin and the Kelvin here, that is also cancelable. Therefore, we're going to get the final units, remaining units, to be grams per liter. So, the final unit of density in terms of ideal gas law is grams per liter. So, every time you are dealing with a density related calculation and you're using PMM over RT, that means the final unit of density is grams per liter. Or if you're given density in an ideal gas law problem, make sure that before you substitute density's value, make sure that the density unit is in grams per liter. If not, you need to convert it first before you substitute it to D so that the rest of the units will be compatible with it. So take note, in the previous calculations of density we had, which is not related to gases, we had grams per ml and then kilograms per liter. But in terms of ideal gas law, in terms of gases calculations, density, the grams is already paired with liter in terms of its unit. So please take note of this particular unit desired for every ideal gas law equation. So let's now proceed to doing some calculations related to the ideal gas law. Okay, let me proceed to that. Okay, what is the density? Of course, it's already stated, and to remind you that it should be in grams per liter, of carbon dioxide gas at 955 torr and 22.5 degree Celsius. So, let's look at our given here. So, of course, we're given pressure, which is 955 torr, which has to be converted to atmosphere because this is an ideal gas law. So we divide this by 760 torr, which you know already. The conversion from atmosphere to torr is divided by 760. So that's going to become 1.26 atmosphere. And then we have temperature of 22.5 degrees Celsius plus 273.15. So we will get 295.65 Kelvin. Okay, and then the formula from the given, we have already converted from the given. The formula we're going to use for density is equal to pressure times molar mass over RT. Now look at the variables that you need. We're done with pressure. We're okay with that. We're okay with T. And of course, R, the gas constant that you need to memorize. What else do we need? We lack molar mass, but we know it's carbon dioxide gas, which is CO2. Now you look at your periodic table. Looking at the periodic table, you have one carbon and two oxygen. Adding the masses of one carbon and two oxygen, so we will get the molar mass of carbon dioxide to be 44.01 grams per mole. Now we have all the variables that we need. So we're ready to substitute that in our equation. The right units available. So pressure should be in atmosphere. So we use 1.26 atmosphere. Molar mass, which we know is 44.01 grams per mole. And then divided by R, which is 0.0821 liter dash atmosphere per mole Kelvin, close parenthesis, and then times temperature, which is already in Kelvin, that's 295.65 Kelvin. Okay, now that's the correct substitution. Before we input that in the calculator, let's figure out whether we can cancel the right unit. So Kelvin gets cancelled out here, mole gets cancelled out, atmosphere gets cancelled out. And so, obviously, we're left with grams per liter, which is the correct unit for density as what we have learned from the previous video. Now we are ready to calculate in our calculator the final answer to this particular problem. So inputting all of that to the calculator, we will get the density of carbon dioxide to be 2.28 grams per liter of CO2. Okay, so now we're okay and we were able to solve the problem correctly. So the answer is 2.28 grams per liter of carbon dioxide. Please check this and take note of this, how we are solving the problem. And if there's a need for you to practice some more so that you can also memorize and grasp the equation properly, please do so. Okay, now we are ready to proceed to the next problem, which is about molar mass. Let us see problem number 2. Okay, it says here, a chemist has synthesized a greenish yellow gaseous compound of chlorine and oxygen and finds that its density is 7.71 grams per liter at 36 degrees Celsius and a pressure of 2.88 atmosphere. So now you are to calculate for the molar mass of the compound. That means you're looking for mm. Okay, now let's look at our given first. We're given density, which is 7.71 grams per liter. And then T is 36 degrees Celsius, in which we need to add 273.15 Kelvin. And so the temperature will now be 309.15 Kelvin. And then we have pressure, which is all right because it's already in atmosphere, which is good. So 2.88 atmosphere. Okay, now the variables are there from the problem. Let's look at our equation. Our equation was density is equal to P mm over RT. We need to get, what do we need to get? This. So what do we need to do is we cross multiply the two. So this is going to become dRT is equal to Pmm. So because we want to get mm, so divide both sides by pressure. So cancel that out. So mm's formula therefore is equal to density times RT over P. And looking at the variables, we got all we need. And it's on the right unit. Because we said before, density has to be in grams per liter, temperature has to be in Kelvin, pressure has to be in atmosphere. So now we're ready to substitute our values. So molar mass is equal to dRT. So D is 7.71 grams per liter. And then R of 0.0821 liter atmosphere per mole Kelvin. And then we have times our temperature of 309.15 Kelvin. And then we divide this by pressure of 2.88 atmosphere. So we're now ready to calculate it. You must be able to get molar mass of 67.95 grams per mole. Okay, that is the